Back in 2014, scientists and researchers revealed a new and much more accurate map of the ocean floor, revealing thousands of underwater mountains and volcanoes that were previously unknown to mankind. Data collected by two satellite observatories, namely the European Space Agency's Cryosat-2 and the Jason-1 operated by NASA and the French space agency CNES, was utilized by researchers for creating this map. Both of these have instruments capable of measuring the topography of the ocean's surface within a fraction of an inch. David Sandwell, a geophysics professor at the Scripps Institution of Oceanography at UC San Diego, who led the study, has stated that it may not seem like a big deal, but instead of seeing 5,000 volcanoes down there, we can see 10,000. Everyone knows a little bit about volcanoes and the devastating volcanic eruptions of the past, including the Pinatubo, St. Helena, Pompeii, and Krakatoa. These explosions caused a huge number of fatalities and immense damage to the surrounding regions. We're all aware of the most recent Hunga Tonga Hunga Hape eruption that occurred earlier this year and rattled the Earth so badly it frightened even the bravest among us. It was the largest volcanic eruption of the 21st century that produced shockwaves that were felt around the globe. However, this wasn't just a one-time event. In the recent decades, multiple above-ground and underwater volcanoes are seemingly rising from their slumber. The 2022 eruption of the Hunga Tonga wasn't a rare occurrence. In fact, much more devastating eruptions have shook the planet in the past, and the underwater eruptions are capable of causing even more damage than the above-ground ones. The largest recorded underwater eruption that occurred in 2018 actually resulted in the birth of a giant baby, a skyscraper-sized underwater volcano. Like the surface volcanoes, submarine volcanoes are also vents or fissures in the Earth's surface from which magma can erupt. The only difference is they exist underwater. A lot of submarine volcanoes are located near areas of tectonic plate formation called the mid-ocean ridges. The volcanoes located at the mid-ocean ridges estimatedly account for more than 75% of the Earth's magma output. Though most submarine volcanoes exist deep in the ocean, some also exist in shallow waters, and these are capable of discharging volcanic material into the atmosphere during an eruption. Experts have estimated that in total there are around 1 million or more underwater volcanoes, most of which are extinct. Around 75,000 of these are more than 1 kilometer above the seabed. Scientists believe that some of the most productive volcanic systems of our planet are hidden under an average of 2,500 meters of water. The magma and lava spewed out by these volcanoes creates the edges of new oceanic plates and supplies heat and chemicals to the rare and unusual ecosystems of Earth. The presence of water can greatly alter the characteristics of volcanic eruptions. Water causes magma to solidify much faster than in terrestrial eruption and thereby turns it into volcanic glass. That's why the shapes and textures of lava formed by submarine volcanoes are different from the lava that erupts on the surface. And below the depths of 2,200 meters in the ocean, the pressure exceeds the critical pressure of water. The water can't boil at this pressure as it becomes a supercritical fluid. But the absence of boiling sounds makes deep-sea volcanoes difficult to detect at great distances using hydrophones. There's a lot scientists still have to learn about the location and activity of underwater volcanoes. But they found out that many submarine volcanoes are seamounts. These are typically extinct volcanoes that rise abruptly from the sea floor at 1,000 to 4,000 meters in depth. Oceanographers define these as independent features that rise to at least 1,000 meters above the sea floor. An estimated 30,000 seamounts occur across the globe, out of which only a few have been studied by experts so far. Back in 2018, mysterious rumbles were detected by seismometers around the world. These were emanating from a generally quiet area in the Indian Ocean between Comoros and Madagascar. At that time, researchers were astonished by what they found, a 2,690-foot tall underwater volcano that was about 1.5 times the height of the One World Trade Center in New York. This volcano was formed after the largest underwater eruption ever detected. Scientists suspect that this volcano derives its lava from the deepest volcanic magma reservoir known to researchers. Initially, scientists took notice of volcanic activity nearly 31 miles east of the French island of Mayotte in 2018. This was triggered by the seismic hums or the low-frequency earthquakes that were detected by seismometers around the world. This huge underwater volcano shocked the scientists as only 2 seismic events had been recorded near Mayotte since the year 1972. Prior to that, only a layer of 4,000-year-old pumice found in a lagoon close by was the only evidence of an eruption. Researchers installed ocean bottom seismometers and GPS systems in order to track the geological activities after they noticed that the island was moving 7.8 inches eastwards annually. In order to understand the origins of these tremors, the team studying this volcano kept a close eye on the area spanning more than 8,500 square kilometers of the seafloor near Mayotte Island. The team was aware there was a magmatic event east of the island, but they didn't know whether the magma stayed underneath the crust or erupted onto the sea floor. The team's equipment recorded 17,000 vibrations from 20 to 50 kilometers below the sea crust. Using all the recorded data, the research team analyzed the seismic waves collected by their equipment, and they were able to piece together how this underwater volcano formed. The area was almost flat before the volcano emerged 8,464 feet below sea level. Strangely, this huge seamount did not appear in the 2014 geological survey conducted by the Naval Hydrographic and Oceanographic Service in France. The colossal submarine volcano formed from a huge magma chamber just underneath the Earth's crust. Tectonic plate movement tore apart the rock in the crust, and the magma rose, forming geological dikes. These are rocks that fill larger holes and cut through the surrounding rock layers. This is the process that created the seismic activity, and as soon as the magma reached the sea floor, the volcano was built up as its lava reservoir drained. The tremors and volcanic activity of this area are still being monitored by scientists. The most recent evidence of magma on the sea floor was found by them in January 2021. The source of this volcano's magma reservoir is around 55 kilometers deep underground. Nathalie Fouillet, a marine geoscientist at the Paris Institute of Earth Physics (IPGP), University of Paris, has stated that this is the first time in volcanology that we can visualize such a deep reservoir at the base of the lithosphere. The volume of material spawned by this volcano is around 30 to 1,000 times larger than any other documented deep-sea eruption. It was more than 3 times larger than the Hava eruption that happened in New Zealand in 2012. And about 2.5 times larger than Iceland's Bardarbunga eruption that occurred in 2014. What's strange is that experts think this isn't the first eruption near Mayotte. According to researchers, large lava flows and cones on the upper slope and onshore Mayotte indicate that such events have also occurred in the past. A few years ago, a volcano the size of New Mexico was identified under the Pacific Ocean nearly 1,600 kilometers east of Japan. This submarine volcano is the biggest volcano on Earth and one of the biggest in the solar system. Initially, scientists thought the shield volcano was a composite of smaller structures, but William Sager, a geology professor at the University of Houston in Texas, explained that they found that it's one huge volcano. According to Sager, it is in the same league as the Olympus Mons on Mars. Tamu Massif is a rounded dome measuring nearly 480 by 650 kilometers. Its top lies almost 2,000 meters below the ocean's surface, and its base extends down to 6.4 kilometers below. The largest volcano on Earth's surface, the Mauna Loa, seems like a dwarf in comparison to this underwater giant. Tamu Massif is made of basalt and is considered the largest and oldest feature of the Shatskis Rise, an oceanic plateau in the northwestern Pacific Ocean. Scientists mapped this rise back in the 20th century. They knew that it was a massive mountain range, but they had no idea what the structure was like or how it formed. Tamu Massif is quite different from the classic seamounts that protrude from the ocean floor around the world by tens of thousands. It's much more enormous with a gentler slope. The slope is just around 1 degree near its summit, while down the flank, the slope is half a degree and it's even lesser at the base. But the seismic data of Tamu Massif was even more surprising than its size for Sager and his colleagues. They found what appeared to be lava flows going out in all directions from the center of the volcano. However, to their surprise, they couldn't find any obvious large secondary source of volcanism. Scientists have concluded that Tamu Massif was formed by a single volcano over a relatively short period of time, and it went extinct soon after it was formed. Sager has explained that this probably happened in the late Jurassic to early Cretaceous period, around 145 million years ago. It's hard to imagine what would have happened if this giant was active and erupting. It's a good thing that Tamu Massif is extinct, but did you know that there's an entire region in the Pacific Ocean where multiple volcanic eruptions and earthquakes occur quite frequently? It's famous around the world as the Pacific Ring of Fire, Rim of Fire, the Girdle of Fire, or the Circum-Pacific Belt. This horseshoe-shaped belt is around 40,000 kilometers long and over 500 kilometers wide. It includes the Pacific coasts of South America, North America, and Kamchatka, and a few islands in the western Pacific Ocean. This ring of fire is a direct result of plate tectonics, particularly the movement, collision, and destruction of the lithospheric plates lying under and around the Pacific Ocean. These collisions have led to the creation of an almost continuous series of subduction zones where volcanoes form and earthquakes occur. This ring of fire isn't a continuous structure, however. The volcanic eruptions in every part of this ring occur independently of those in other parts. This ring alone contains 2/3 of the world's total volcanoes. There's approximately 850 to 1,000 volcanoes in this ring of fire that have been active during the Holocene. In fact, the 4 largest volcanic eruptions on Earth during the Holocene epoch occurred at volcanoes located in this Pacific ring of fire. And along with the currently active and dormant volcanoes, there are also belts of much older extinct volcanoes here that were formed long ago. The world's highest active volcano, Ojos del Salado, is located in the Andes Mountains section of the Pacific Ring. It last erupted in 750 AD, according to experts. Nearly 76% of our planet's seismic energy is released as earthquakes in the Pacific Ring of Fire. The Ring of Fire is located just over 60 kilometers from the island nation of Tonga, where the Hunga Tonga Hunga Ha'apai volcano erupted this year. Scientists were previously unable to decipher why the eruption of this underwater volcano was so explosive, but now they're starting to piece it together. The evidence collected by 2 teams indicated that when the volcano erupted, it spewed a massive amount of magma that violently reacted with the surrounding water. This in turn powered several large blasts and hundreds of smaller explosions. On the 15th of January 2022, the Hunga Tonga volcano erupted and produced the largest atmospheric explosion in recorded history that sent a plume of ash into the upper atmosphere. Volcanologists who studied the caldera of this volcano after the eruption found out that it had dropped in depth from 200 meters below sea level to almost 850 meters. Almost 6.5 cubic kilometers of rock were thrown out as a result of this massive explosion. Tonga's Deputy Secretary for Lands and Natural Resources in Nuku'alofa and a collaborator on the research thinks it creates a better picture of the mechanism of the volcano. An expedition by a team at New Zealand's National Institute for Water and Atmospheric Research sampled the ash from this explosion and found out that it was followed by dramatic pyroclastic flows. The onrushing hot ash turned the seafloor into a white desert that wiped out everything. These flows spread for thousands of square kilometers underwater and even ripped up the seafloor cables, including the ones providing internet access to Tonga. Some of these still haven't been fully restored. Scientists think this ash sediment is so toxic that even bacteria probably can't live there. Experts are hoping that this incredibly powerful eruption was a one-time event because mankind is definitely not prepared to handle more of these. Do you think explosions like these are going to become more frequent in the coming centuries? Tell us in the comments below.